Hello Internet, my name is Quinn and this is Blondihacks. Something I get asked a lot is, are there practical around the house things that one can use hobby machine tools for, presumably to justify the purchase of same to yourself or to a spouse? And the short answer is no. The long answer is maybe we can come up with some thin excuses to use these machines for something other than making model engines or making tools to enable the creation of other tools until one day you're found dead in a giant pile of tools. It's a good way to go though. So, I've got such a project today, and maybe it'll be the first in a series called Machining Around the House. So let's go. Step 1, define the problem. This is my shower door, and it's got this blanking plug on one spot where a handle could go, and then on the other side there's a handle on the inside there. So that means that you can close the door from the inside, but you can't open it from the outside. Meanwhile, the other door has this large handle / towel rack thing on it, which you can use to open and close this door from the outside. But then again, the back is flat between the doors, so there's no way to close that door from the inside. So neither door has a way to both open and close it from inside and outside, which I find really annoying. Now, the reason they do this, of course, is so that it will clear the door and the doors can slide past each other, but I don't actually care about that. So what I want to do is make a new handle for this side that will have a plastic insert right where the handle will contact the glass on the other door so that it won't clang or otherwise be unpleasant, and it'll just replace this blanking plug. These things have little holes on the side that can be used as like a pin spanner hole if you need, but honestly, I don't find it necessary. These things are just finger tight and they untwist thusly. So I'm going to use the threaded end of this blanking plug, and I'm just going to remake the other half of it to make it like a new handle for this side. And I'm going to do my best to copy the factory handle. And then there's some plastic insert pieces there that I'll need to reproduce as well. So I'll take the factory handle with me out to the shop because I want to copy the shape of it as best I can. I don't know if I'll be able to match the quality factory polished finish there, but I'll see what I can do. I'm going to do my best to match it in every way, except that there will be a plastic section in the middle of it to act as a bumper on the glass. For this project, I have some stainless here of unknown alloy. Previous me just marked it stainless, so I guess I'm not sure what it is. Might be exciting. And then I've got some Delrin there as well to make the plastic parts. And here, once again, is the factory part that I'm trying to copy. So let's give this a go. Luckily, I've got plenty of this stainless, and actually it turns out I don't need to cut it because it'll fit through the spindle bore, which is always nice when that happens. So I'll choke this up like so, and we will face off the end as is tradition. For cutting lubricant throughout this project, I'm using this green paste, which is Anchor Lube. It's supposed to be good for stainless, and I have a lot of it, so I want to use it up, and I don't know, seems to work fine. It does smell a little funky as it burns off. I mean, not that cutting oil smells like roses either, but, you know, it has a very different smell that you may like more or less than traditional cutting oil. That finish seems good, and this stuff seemed to machine okay, so it's probably not some really gnarly stainless like 416, it's probably 303. It's machining pretty easily. With any somewhat unfamiliar material or material that I'm a little nervous about, I'll start with a lighter cut like a 20 thou pass, that's 10 thou depth of cut, and work my way up from there and just see how the machine feels and sounds, and if it's struggling or if I start to get chatter or other issues, then you know when to kind of back off a little bit. In this case, I worked my way all the way up to 50 thou passes, and it was still turning just fine, and that's plenty for one pass. I don't have that much to remove here. Obviously, I chose stainless for this because it is a wet environment, being a shower and all, but I honestly wasn't sure if I was going to be able to do this in stainless. You know, stainless is a tough material, and it's a material that I don't have a lot of experience machining. I'm going to be doing a lot of things that I've only ever done in brass. So this is an experiment, and plan B, if this does not work out, is to do it in aluminum, which will be easy and also resistant to the water, of course. The finishing pass got interesting here because this stuff wouldn't break a chip with this particular insert. This is my go-to insert that I've talked about lately, which is actually spec'd for aluminum, so it doesn't really have a chip breaker profile in it that would work on steel, but it does do a very nice job. Next step is I need to identify the thread on this backing plug here. Sure enough, it is M61, which is not at all surprising because most of the world these days is put together with M61 or quarter 20 bolts. So now I can center drill, and tap the bottom of this piece here. Now, this is actually not the bottom of the handle as you might expect. What I'm doing here is I'm making a cap that's going to become the top of the handle. Because remember, I want a plastic insert in the middle of this piece. So what I'm going to do is essentially make an assembly or a composite piece of material, if you will, that has stainless on the outside ends and then the piece of Delrin in the middle. And the Delrin is going to be wrapped around a stainless steel shaft. So there's going to be stainless all the way through the middle for strength. So this hole here is going to thread onto a mandrel that will be sticking up out of the base and form the complete assembly. It'll all make sense here in a minute. Stay with me. With my spring-loaded tap follower in the tailstock there, I'll get my M61 taper tap in here, get a little bit of the green goo on there, and tap away. This is not a very deep hole, so the taper tap did not get far at all, and I had to bail on it and go right to the bottoming tap, but at least the taper tap helped start things down the right road there. I was a little bit worried about tapping this stuff because, again, stainless, drilling and tapping it can sometimes be ornery, but actually this went okay. These taps are both sharp, and while it was tough going, I could definitely feel the toughness of the stainless. It did go okay. And actually the result is quite a beautiful thread there. Really pleased with that. A quick test fit here with the factory plug to make sure that's going to go in, and that looks good. Now again, the factory plug won't be threading into this hole, but I'm creating the same thread type and depth to assemble the two pieces together as well, just to keep everything simple. All right, I'll break that sharp edge there, just kiss it with the file, and we are good to part off this cap piece now. So I'm going to find the edge there with the parting blade and my scale, and then I'll set up a dial indicator there on the carriage to move over the correct distance. At the top of the show, you saw me measure the distance between the glass panels there to figure out where the extents of the plastic insert need to be. So the length of this part is the distance to the end of the knob from the top of the plastic insert. Now, I was pretty nervous about this, I'm not going to lie. I don't think I've ever tried to part stainless before. And again, I don't actually know which alloy this is, so I don't know how much of a ride I'm in for here. But I went real slow and used lots of the green goo, and this actually seemed to go okay. When in doubt with parting, just go slow. I think the other key to parting stainless or any other tough material is to keep even pressure on that cutter. Make sure you've got that chip forming continuously. Don't let that parting blade rub, and don't be uneven with your pressure because then you can get the blade skipping and chatter will start. And Yahtzee. Now, you might notice that hole right there, and we'll come back to that in a minute. Yes, that's a problem, but hold your comments. Well, that part went pretty well, I have to say. That surface finish is not going to win any awards, but I'm pretty pleased that I was able to part off this stainless at all. So I'll clean up the mess from that, and we can get to turning the base here of this part. I'm turning this down to the major diameter of M6 once again because this is going to thread into that cap that we just made. So I turned that whole thing down. Now the lower section of that is going to act as a mandrel for the Delrin. And then the top section I'm going to turn down a few thousandths more because this is where the thread is going to go, and the die needs a little bit of clearance below the nominal size of the thread. So in with the M61 die now. Unfortunately, I only have the hexagonal dies in metric. So I've got this ratcheting tap wrench here, which people always ask about. It's linked in my notes below, so if you want to pick one of those up, they're quite handy on the lathe because of that ratcheting action. The nice thing about these dies is that they have the option that some do where there's a taper on one side only, so you can flip the die over and get a little closer to a shoulder if you need to. So that'll finish up this thread here nicely, I think. I'll just double check that I've got enough room for the Delrin there with a little bit of the thread sticking into the Delrin so that the cap will squeeze tight against it, and that looks good. So I'll clean up the end of that thread, and I'll do a little test fit here with the cap, make sure that's going to go on there nicely, and that looks good. So you can see where the Delrin is going to go. Now, speaking of the Delrin, if I was smart, I would have made that part first, because now I have to remove this stock from the 3-jaw and lose my jaw position. But I've marked with a line there where the 0 pinion is on the chuck, and I've marked the front edge of the jaws. So I can pull the stock out, and I'll be able to put it back very close to where it is now on concentricity. Not that concentricity matters for a shower handle, but, you know, it's a good technique for the future. Out with the steel and in with the Delrin now, and I will start by facing off the end of this, as is tradition. Now, white Delrin is notoriously difficult to photograph, so take my word for the fact that that blinding blob of white pixels in the middle of your screen is a piece of Delrin round bar. So I will now square up the tool post and figure out about how much I need, put a witness mark right there, and I'm going to turn down the overall diameter of this to the same as the 2 stainless steel pieces that I turned earlier. Because this is Delrin, you can basically do it in one pass. You can do essentially infinite depths of cut, but I still tend to do one roughing cut and one finishing cut, even though it's kind of unnecessary in Delrin. Then I will center drill and drill this through 6mm, which should be a very close fit on the mandrel that we turned there. Delrin is very stretchy, so you can essentially create a hole the same size as the thing you're going to slide it over, and you can get it to go over. Then once again, find the end of that with the scale there, just feeling for the edge of the parting blade, and then move over with a dial indicator to the correct width, and I'll part this guy off. And once again, being Delrin, you can pretty much just ram the parting blade through as fast as you like, and it's just fine. Delrin is actually quite fun to machine, because you can just kind of go crazy with it. Alright, we should be done with that for the moment, so I'll bring back in the stainless steel bar, and I'll line up the axial line there with the 0 pinion, and line it up with the jaws there on the other marks and spin that up, and boy, that looks really good. Just for giggles, I'll put the indicator on it. Yeah, look at that. That's actually concentric to within 1,000th. So that 0 pinion trick really does work well. That's one that I learned from my viewers, actually, because the pinion marked 0 is the one that they used to preload the jaws when they ground them in place on final assembly. So the whole chuck repeats the best if you always tighten with that pinion. The Delrin is a tight fit on there as predicted, so I'll bring in the tailstock for a little muscular support there and just kind of squish that guy on there. And that looks good, so now I'll go ahead and thread the other piece on there. And that fits on there well. Now, remember that that piece has that little hole in the middle? Yeah, that's because I drilled and tapped the hole too deep. So when I cut it to length, it poked through. So it was going to be more work to fix that than to just make it again. So when you weren't looking, I flipped that stainless steel bar around and made this part again on the other end. So here's a new part with the hole that is shallower and not poking through the back. And now we are back on track. So this is essentially that composite piece of stock I was talking about at the top of the show. And now I can start working on getting the profile of the knob into it. And then we'll have, hopefully, the knob with the piece of Delrin right where that glass is going to hit it. I'm going to start with step turning to kind of rough in the shape of the knob here. So I'm looking for a landmark for the skinniest part of the knob, which actually happens to land right on this edge there between the Delrin and the stainless. So that'll be my first landmark. Now I would normally do a step turning like this with the parting blade because it's thin and will give me better resolution. But because it's right on the interface of those two materials, I'm going to switch to this grooving tool, which won't deflect into the softer material the way that the parting blade would. But because it's a wide cutter, I'm going to have to be a little careful in the stainless with it here. This is okay here because the grooving tool is only half in the stainless and half in the Delrin, so it's cutting just fine. So I'm going to bring this all the way in essentially to the narrowest dimension of the factory knob there. A little bit larger than that. I want to have room to file and massage the shape down to final shape and dimension at the end. For my second landmark, I'm going to use the other Delrin interface there, and in this case I'm going to mark that spot on the factory knob where that edge happens to land, and then I measure the diameter of the factory knob at that point. And then I use the grooving tool once again to bring this section of the stock to a little bit larger than that diameter. For the rest of the cuts, I then move over from one of those existing edges, the width of the grooving tool, and I mark that spot on the factory knob. And again, I measure the diameter at that spot. So I'm essentially mapping out the factory knob, one grooving tool width at a time there with the Sharpie and a caliper, and bringing in each area to roughly that dimension. When it comes to do the end of the knob on the outboard side there, I do the same procedure, but instead of using the grooving tool, I'm using the turning tool because the tool pressure is lower and I have a lot less rigidity out here, not just because of the distance from the chuck, but remember that outer piece is just threaded on, so it's not nearly as strong as the stock further inboard is. At this point I switched to the file to try and bring in the final shape from that step turning. And well, this is where my inexperience with stainless starts to show, because while you can see me making progress here, this is very, very slow. Stainless is tough stuff, much tougher than even mild steel, and frankly I'm used to working with brass mostly, so it was way too soon to go to the file. I really needed to do a lot more step turning. And in fact what I figured out works really well is to use a small round nose tool. This is a tool that I use for cutting the base groove in a thread when I'm single point thread cutting. And this worked really well as kind of a shape refining tool. So I used the kind of etch-a-sketch method, if you will, of just manipulating both hand wheels and just kind of massaging the shape here using light cuts, but with this round nose tool I could really go in and out anywhere I needed to and create the curve just by eye, trying to match the factory knob as best I could. Then I would go back to the file and remove the tool marks from the round nose tool, and if the shape wasn't quite right, then I'd come back in with the round nose tool, do some more of that, and then go back to the file and so on. And I'm using a combination of a flat smooth file here and a round file. This technique worked really well. The only limit here really was my own artistic eye. You can see that my shape there is not quite right because I just don't have the eye for matching curves that maybe a real artist would. So you'll see by the end that I don't get the shape quite right, but it's not bad for a software engineer. With the outer knob more or less done, I did the same thing for the base, again starting with the step turning there, and then this time I went straight to the round nose tool to knock those corners off and refine the shape here, etch-a-sketching my way around, trying to match the curve of the factory knob by eye as best I can, and then once again alternating in with the file frequently to remove the tool marks and refine the shape a little bit as I go. So I definitely recommend this technique. Etch-a-sketching the knobs to create the curve that you want is really quite effective. It's not as hard as it sounds, and again, the real limit is just my own eye for matching curves between two different things. The other challenge I ran into here was surface finish. If you look closely here, you can see that I have chatter marks from the filing. And this is a combination of, again, my inexperience with working with stainless and probably running the lathe too fast and also not really having the right files. So a proper set of lathe files probably would have been better. They're designed to run at these speeds. So I did my best to use some emery to kind of clean up the file marks, but I didn't really have a lot of success with that. The stainless is sufficiently tough that emery just didn't feel like it was even really touching it. Really, I was just being impatient though. I should have spent more time with the emery and smoothing that surface out before moving on to the next series of finishing steps, as you'll see. But in the end, I learned a lot doing this, and I think the final result is going to be okay. So we're now ready to part this thing off, so away we go. This is the third or fourth time now I've parted the stainless bar, and it still makes me nervous every time. You can really hear and feel how hard that parting blade is working in there, and it feels like it's gonna work harden and grab and snap at any moment, so I'm taking my time and using lots of green goo to try and keep things moving, and luckily this all went really well, but parting stainless is not my favorite thing, I will say. And that's it. I need a threaded hole in the back of this now, and I figured the collet chuck was my best chance at doing this. The outermost diameter of the knob and the base are both the same, and they both match the size of a collet. So I was able to just kind of grab the edge there with the collet, and then the knob on the inside is also being squeezed by the collet. This was a little sketchy, but actually seemed to work okay. So I was able to face off the detritus there from the parting at the bottom. And that actually left a really nice finish. And then I can come back in with the center drill and once again the tapping drill for an M61 thread. So no drama here. I was a little bit worried about this step because I wasn't sure how I was going to hold on to this monstrosity, but this worked out just fine. If this had not worked, I think plan B would have been some sort of packing block arrangement in the 4-jaw chuck to kind of squeeze it from the middle or something, but luckily I didn't need to resort to such shenanigans. And like I said before, the tapping is tough going in this stuff, but boy, it leaves beautiful threads. Stainless is growing on me, I'm not gonna lie. Alright, quick test fit now with the factory backing plug there, and this is how that's eventually gonna go, so that's important, and that seems to work really well. So the machining should be basically done now on the knob. Now let's see if I can improve the finish and try to get as close to the factory as I can. I'm gonna start on the Scotch-Brite wheel because this thing is basically a miracle at hiding machining crimes, and my plan was to remove all of the tool marks and file chatter marks from the stainless with this step. Now again, my inexperience with stainless showing it's so much tougher than other materials that what normally the Scotch-Brite wheel has no trouble removing, it wasn't really able to do here. It certainly made it a lot nicer, but it wasn't able to fully remove all the little fine tool marks and chatter from the files. Next I swapped in the buffing wheel, and the green compound that I'm using there is specifically for stainless. And I'll see if I can bring out a shine here from what the Scotch-Brite wheel left. And this is actually working really well. This is shining up beautifully. So I'll keep going here with this compound. Now, you're really not supposed to mix grinding and buffing wheels between stainless and mild steels because the mild steel particles can get lodged in the stainless when you switch to that and cause the stainless to corrode, but I'm a hobbyist and this isn't food safe stainless that we're doing here, so I think it's going to be okay. So that's where I got to after the buffing, and I'm happy with the result, but you can see the mistakes that I made there. I made the classic metal finishing rookie mistake, which is I moved on to the next stage of refinement before the previous stage was as good as it could be. So I was counting on the Scotch-Brite to remove the chatter marks, and it didn't, and then I went ahead and did the buffing anyway, so now I have buffed chatter marks. But, from 5 yards away where you're going to be seeing it day to day, I think it's just fine. Wait, what's this? I thought we were done. Well, I did a test fit on the shower door and realized that the factory backing knob threaded section that I was counting on reusing is too short for a handle. It actually only goes just through the glass, so it's enough to grab the flat backing plate of the other piece, but not long enough for a knob. So I had to make one of those as well, which you can see me doing here, and then I Scotch-Brited and buffed that up as well. Then I had to go back to the Delrin as well because it turns out I can't reuse the factory plastic inserts either because those need to be shaped differently for a knob. These inserts act as part water seal and part cushion to protect the glass, so they are important. Well, here are all the pieces now. Here's the factory blanking plug that I'm replacing, and here are the plastic pieces that I just made, the new spacers, and then on the right here is the factory plug for the original handle, and then on the left is the one that I just made. You can see my thread's a little bit shorter than theirs as it needed to be. And then on the right there is the factory knob, and then on the left is the one that I made to replace it. And once again, the shape isn't perfect, but from a distance, I think it'll look okay. So let's do a test install on the door now. So the plastic inserts go together like that, and they fill most of the hole, although they're a little on the small side. I took the measurements from the factory ones, annoyingly, but that's okay, it'll still work. And then the knob thread's on there, and then just tighten that up. Now I didn't put the spanner holes in my backing plug. I find that just hand tightening or a smooth jaw plier is enough to get it tight. And now you can see how the plastic insert lines up with the glass and acts as a little bumper. And so that will prevent any weird clacking or clanging or cracking of the glass. And then I can reinstall the factory handle on the inside. And now that door that I use to get in and out of the shower has handles on the front and back. And of course the doors can no longer move past each other, but again, that's not a feature that I care about. In many ways, this is my favorite kind of project. I pushed my skills in many areas. I worked with a challenging material for me. I learned a lot about shaping and metal finishing. I did some buffing, which I don't do a lot of, got some really good results there that I'm happy with. I learned a lot, and I ended up with something that's really going to be useful and is going to solve a real problem in my life. That shower door situation was really annoying me every single morning when I got in and out of the shower, and I had no way to pull that door open from the outside. Happiness is the summation of a lot of little things, and this will make me a little bit happier. I hope watching this video made you a little bit happier, and thank you for watching it, and thanks to my patrons for making all this possible, and I will see you next time.